Hello, welcome to another college math video. In this video, we finish our journey with logic and we look at kind of the ultimate big picture goal of this, which is to be able to determine if conclusions that are drawn are valid or not. So our objectives for this video, we're going to look at vocab relating to arguments and conclusions, determine whether a statement is valid or invalid, translate arguments into symbolic form, which we've already done, and then determine validity, a kind of new piece here, but it's a small one, and then ultimately reach a conclusion given an argument. So, our notes. Let's define what it means to be valid or invalid in terms of the truth table. So, for valid, an argument is valid when its conclusion necessarily follows from a given set of premises. I think the key word in this definition is necessarily. It doesn't feel like a big one there, but an argument's valid when the conclusion must follow. It necessarily follows. It has to follow based on the given set of premises. Kind of a clunky definition. I think this is a little easier to digest in terms of the truth tables. If it's all true, then it's a valid conclusion. When we look at our truth tables, of course, we'll go through the whole thing. And before we looked at two ends of the spectrum, we looked at tautology and self-contradiction. Tautology being the case when everything was true, self-contradiction being when everything was false. Those are the two extremes. Now we have valid and invalid. It's either valid or invalid. So if they're all true, then it's valid, and invalid is the opposite. Kind of clunky definition, but we'll summarize it. This could also be known as a fallacy. And something is invalid when its conclusion does not necessarily follow from a given set of premises. So valid or invalid, everything is either valid or invalid. Valid is when everything is true. Invalid is everything else, and it's tempting to say, oh, well, then it must be when everything's false. But not necessarily. It could be that everything's false, but if at least one thing in the final column is false, then that conclusion does not necessarily follow in all cases. So, any false in final column. I should say that for the other one too. It's if all true then valid, if all true in the final column. Not through the whole table. In the ultimate analysis, what do we have? All right, so the idea of determining if the conclusion is valid or invalid, again, remember you're a lawyer throughout this chapter and your client says this, blah, 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 here are all the facts. Therefore, what? What's the conclusion that's drawn based on all of those facts that they present to you? And so that's this setup of premises leading to a conclusion. So let's use some colors and fill in. I guess we'll stick with red. No. Let's go purple. So there'll be a first thing that's said, blah, 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 blah. They're saying this is something that happened. This will be symbols or words, and then we'll translate it to symbols. But I want to use colors to give you the basic framework of what every scenario where we're determining validity looks like. We'll have a premise 1. We'll have a premise 2. Again, there'll be a sentence said, I did this and this and this and this. And it could be a complex idea. There could be more than one thing involved. It could be an if-then statement, something and something else, or it could be one simple idea. And then ultimately they'll say, therefore, something. No, we can't do green. Let's do black. Therefore, what? What's the conclusion that's drawn based on that information? This symbol that you see with the 3 dots means therefore. So that's your clue. If you see therefore or something similar to it, then you know everything that follows this is the conclusion. And typically the premises will be set up as individual sentences or individual symbolic statements. So basically when we're drawing a conclusion, or when someone's presenting information to you like this and then drawing a conclusion, they're saying, if this first thing and this second thing that I'm saying are true, then this is the conclusion that follows. And so that's kind of the grand idea that we're looking at here. This is how you'll set up every single one of these. If this first premise and this second premise are true, if this first premise and this second premise are true, then my conclusion follows. This line right here, this whole statement, however many symbols it involves, is what we're running through the truth table to then ultimately determine if it's valid, they're all true, or invalid if there's any false in that final answer column. You might see, this is what you're going to run through the truth table, and right now I have the words premise 1, premise 2, and conclusion set up there, but you won't necessarily see those things there. You might just see them presented like this. You might just see the one idea. Again, that idea will be symbols. You'll see another idea. Symbols could just be one letter, could be P and Q, could be negation P and R, whatever it is. You'll see a line, you'll see the therefore symbol, and then you'll see the conclusions in symbols, whatever it is, one, multiple symbols. And every single time you'll pull this into this statement. Premise 1 goes in this spot. Let's list that there. Premise 2 goes in the second spot. And the conclusion goes in the third spot. Because in all cases, we're saying, if this first premise and this second premise are true, then here's the conclusion I draw. And we're testing if the conclusion is a good conclusion to draw or not. You might also be wondering, will the symbol ever be or? No, it's always and. It's always you're saying, if this first thing and this second thing, and in the real world, certainly there'd be many more premises leading to a conclusion. So obviously in the real world, truth tables could get very complicated. We're only going to see 2 premises leading to a single conclusion. But you certainly could have more, and it would just be premise 1 and premise 2 and premise 3. They would all be in this parentheses, this and this and this and this, leading to single conclusion. All right, so let's do an example and see what that looks like. So, determine if the conclusion is valid using a truth table. We have ideas presented in words. We're going to have to go to symbols, test the truth table. So we have, if Carrie Underwood sings the national anthem, then the Who will play at halftime. Carrie Underwood sings the national anthem. The conclusion that's drawn based on those 2 premises is that the Who plays at halftime. We're going to test via truth table if that's a good conclusion to draw based on the first 2 premises. So let's first identify what can be deemed as true or false here, all the different ideas throughout any of these statements. One of them certainly, idea P, we'll just start with P, is that Carrie Underwood could sing the national anthem. That could happen or it couldn't happen. Carrie Underwood sings national anthem using a little shorthand. Another idea throughout these statements that can be deemed true or false, the Who playing at halftime. And it looks like anything else we see here, nope, they're all even the same version. So those are the only 2 ideas we have here. So let's go ahead and translate each of these premises and conclusion. The first sentence can most definitely be viewed as premise 1, and that's typically how it'll break apart. Sentence, sentence, sentence. Premise, premise, conclusion. So if Carrie Underwood sings the national anthem, then the Who will play at halftime. Premise 1 is what symbolically? It's an if-then statement. If Carrie Underwood sings the national anthem, which is P, then The Who will play at halftime. Q. The second premise is that Carrie Underwood sings the national anthem. So the second premise, the second line here, is P. Then the conclusion that's drawn, there's no therefore written there, but we see the word conclusion, so we know that's what's coming next. This little 3-dot symbol should be there if you're writing it in this format, and you'll see it written in that format in the online system. The Who plays at halftime. This is the conclusion, idea, Q. Sometimes each of these pieces will be more complicated. Sometimes they'll be simple like this. So let's take this and translate it into the symbols we need to test in the truth table and then run the truth table. So remember the basic setup. If premise 1 and premise 2, then conclusion. Premise 1, if P, then Q. And since there are more than one idea there, I'm going to go ahead and put that in its own parentheses. Premise 2 is idea P. Don't need parentheses. It'd be fine if you put them there, but you don't have to. And the conclusion drawn is Q. So this statement is what we're running through the truth table. If we get all true in the final answer column, it's valid. Any false, it's invalid. So let's start to build that truth table. We only have 2 ideas, P and Q. So we only need 4 rows for this table. Remember our basic framework. True, true, false, false, true, false, true, false. It doesn't look like we need any individual negations, so we don't have to start there. We can't quite do the whole thing yet, so we focus on the parentheses first. Inside the parentheses, we have another parentheses, so let's start there. If P, then Q. Remember, our only problem is when true leads to false, so that's second line. Everything else is true. Now that we have this piece, we can do the whole parentheses. So if P, then Q, and P. The symbol that we care about is the and symbol, and we're pulling together P, and if P, then Q. Remember with and, the only way we get true is if they're both true. So it looks like our first line, and that's it. And now that we have this parentheses, we can do the big picture, the whole thing. If P, then Q, and P lead to Q. It's always important to know which symbol you're focusing on for that column. Anytime you're filling in a column, you're only focusing on 2 other columns, 2 columns that give you this next column. The symbol is the conditional, and we're pulling together the, that's okay, the parentheses here, and that one has to be first because it's before the arrow, and the Q, this one has to be second. So we're comparing from right to left these 2 columns. And again, it's conditional, so it's only false when true leads to false. True to true, false to false, false to, doesn't matter what false leads to, it's true. So we can make our ultimate decision. Is this a valid conclusion to draw based on the premises? Did we get all true in the final answer column? We did. So this is a valid conclusion to draw. So let's take a step back and just quickly debrief on what we did. We looked at the whole set of statements. We identified the premises, which were the individual sentences, and the conclusion. We decided what the ideas were that were true or false so that we could translate each of those premises and also the conclusion. Then we took those symbols and plugged them into the formula that will be true for all times that you're testing if a conclusion is valid or not. Premise 1, premise 2, conclusion, just plug them into those spots and then test that whole statement in a truth table. If it's all true, valid. If any false, then it's invalid. Lots of steps, but this is the ultimate goal of this whole chapter, to be able to decide if the conclusion that's drawn is a valid one or not. That's one of the big ones. The other is to actually draw your own conclusion, but we'll see that later in the video. All right. So let's go ahead and practice using exactly the same process. We've got premises and a conclusion. If you watch Good Morning America, then you see Robin Roberts. You did not see Robin Roberts. Therefore, you did not watch Good Morning America. Therefore is your indication that what's coming next is the conclusion. So go ahead and go through the whole process just like we did on the last slide. Pause the video. We'll see if we're on the same page. All right, so let's test it out, see if we're together. The ideas that we can deem true or false here are watching Good Morning America and seeing Robin Roberts. Whoops, Q. All right, no other ideas here that are unique that can be true or false. We see some variations on these ideas, negations, but not anything special. So, premise 1 is this first sentence. If you watch Good Morning America, then you see Robin Roberts. So, it's an if-then statement. If you watch Good Morning America, then you see Robin Roberts. If P, then Q. Second premise is your second statement. You did not see Robin Roberts. So, negation Q. And the conclusion that's drawn, whoops. The conclusion that's drawn, therefore, the line tells you what's coming next is conclusion. And the dot, dot, dot. You did not watch Good Morning America. So, negation P. So we take this, translate it into our formula. If P, then Q in the first spot, negation Q in the second spot, and negation P in the third spot. You might be wondering, why do I even have to write it this way? Why couldn't I go right to this? If the question is just asking you to test validity, you certainly could do this. This format is a way that you're going to see problems presented quite often in this section, so I just want you to be used to it. So now we test via truth table. Again, thank goodness, 2 ideas that can be deemed true or false here, just P and Q. So we only have 4 rows. Now, ultimately we want this whole thing. We have a couple individual negations, so I'm going to come up with those just to knock them out. Remember, a negation is simply the opposite of Q. False, true, false, true. Now we look at the parentheses. Looks like we have a parentheses inside parentheses, so we'll do that one first. If P, then Q. Remember, our only problem is when true leads to false. True leads to false in the second line. Everything else is true. Good to go. Then we can do the whole big parentheses. I'll just keep here. If P, then Q, and negation Q. The symbol that we care about is the and symbol, pulling these 2 ideas together, the parentheses and negation Q. And tells us they need to both be true, ultimately to be true. So looks like the only one we get that in is the last one. And then finally, we can do the whole thing. I'll write the whole thing. Negation Q leads to negation P. The symbol that we care about here is the conditional, and it comes from the one we just did, and negation P. First parentheses, second negation P. The only time we have a problem is when true leads to false. Looks like we don't have that, so they're all true, meaning this is a valid conclusion to draw. So again, big picture, we decided what the ideas were that could be true or false. We translated premise 1, premise 2, and the conclusion. We put them into this formula, if premise 1 and premise 2, then conclusion. We tested it via truth table, got all true, so it was valid. The majority of this chapter is doing something like this, but there's a couple more ideas we're going to look at, so let's take a look at those now. not the majority of the chapter. The majority of this section is doing something like that. Okay, so let's list a couple standard forms of argument that can be used, meaning a couple conclusions that can be drawn from given premises, but in symbols. And then a few that are often mistaken for being valid but are actually invalid. So the first ones that we're going to list are the ones we already came up with. Good. The first problem we had if P then Q as one premise, P as another premise, and the conclusion that was drawn was Q, and this was a valid conclusion to draw. We tested via truth tables, so it was proven. Essentially, this says if a first thing leads to a second thing, and that first thing happens, we can conclude that the second thing's going to happen. Valid conclusion to draw. The second one that we just did, premise 1 was if P then Q, premise 2, negation Q, and the conclusion that was drawn, negation P. And we already tested via truth table that that is a valid conclusion to draw. Now, the others that I'm going to list, I'm only going to list 2 more, but there are definitely way more that exist out there. The other 2 that I'm going to list, I'm just giving you the valid conclusion that's drawn. And you don't have to prove it, you don't have to test it if you don't want to, but it is something you could be asked. I might ask you to prove any sort of problem for validity. So the next one we have, if P then Q, so if a first thing leads to a second thing, and that second thing leads to a third thing, a valid conclusion that can be drawn is that the first thing ultimately leads to the third thing. It's like the domino effect. If the first domino causes the second domino to fall, and the second domino causes the third domino to fall, then ultimately the first domino is what's causing the third domino to fall. If the first thing happens, the third thing is going to happen. And then one more that we'll list together here. P or Q, and negation P. Remember with or, could be one, could be the other, could be both. So if we say, I like this or I like that, well, I don't like the first thing, the conclusion you can draw is that I must like the second thing. If it's this or that and the first thing doesn't happen, then the second one's going to happen because it was one or the other. Similarly, these 2 symbols could be flipped because it's an or statement, but the general idea is there. So these are valid conclusions to draw. A couple invalid to draw. These are not valid, but I want them listed so that you don't make the mistake. So if a first thing leads to a second thing, and that second thing happens, it's an invalid conclusion to draw to say that, well, the first thing must have led to it. It's not necessarily the case. That second thing could have happened because of something else. We don't necessarily know what would have happened. So this is one that people often assume must have happened, but not necessarily. That one's invalid. And you could test it via truth table through the whole if this and this, then this, if you want to. And the other one, if the first thing leads to a second thing and the first thing does not happen, an invalid conclusion to draw is that, well, then the second thing doesn't happen. Not necessarily. If this first thing doesn't happen, again, we don't know anything about what the second thing would be. The tricky idea behind the conditional. So this is an invalid conclusion to draw. I would be much more concerned with the valid conclusions, but just so you know, these are a few that are invalid to draw. And again, there are many, many, many more valid conclusions and invalid conclusions. These are just a few examples using the symbols that we've seen throughout this chapter. Okay, and then let's look at our other goal with this section in particular is to be able to draw a conclusion. So we're given premises and we're going to draw a conclusion. So draw a conclusion using the standard form of argument. What we saw on the previous slide were some standard forms of argument. And then we're going to also show the standard form of valid argument used. So it's going to have to fit one of the molds that we just saw. All right, so this example says, I am stressed out or I have the flu. I don't have the flu, so what conclusion can we draw? 2 things we're going to do. Draw the conclusion and show the standard form of valid argument. So let's start with that valid argument. What are the ideas that we have that can be deemed true or false here? Stressed out we'll call that P, and having the flu, idea Q. So premise 1 says I'm stressed out or I have the flu, so P or Q. Premise 2, I don't have the flu, negation Q. So based on what we saw in the last slide, what conclusion can we draw here? If it's P or Q and it's not Q, then it has to be P, which means the ultimate conclusion in words we can draw from this, if I'm stressed out or I have the flu and I don't have the flu, then I'm stressed out. I am stressed out. I'm doing all right, but I hope you're not stressed out. But this is the conclusion you can draw from these premises. This is the standard form of argument that we saw in the previous slide, those examples of valid arguments, and then the conclusion that can be drawn, the valid conclusion, I'm stressed out. Okay, another example. If you close the deal, then you will get commission. You did not get commission. So let's figure out what the standard form of argument would look like. What are the ideas that can be deemed true or false here? Closing the deal. We'll call that P. And commission can be Q. So premise 1, if you close the deal, then you get commission. If P, then Q. You did not get commission, so negation Q. The standard form of argument says the conclusion we can draw is negation P. So ultimately, negation P, you did not close the deal. So that's the idea here. Two things to show, the standard form of argument, and then ultimately making your conclusion. All right, so let's go ahead and practice this a little bit. Pause the video. This is the same thing that we just did. Do both things, test validity. Test validity. Nope, we want one of each. Test validity using a truth table, and then draw a conclusion using the standard form of argument and show that standard form of argument. Two different types of problems. All right, let's see if we're on the same page. So our first one, we're testing validity, so we're going to build the truth table. If the car is a roadrunner, then the car is fast. That's definitely our premise 1. The car is fast. That's our premise 2. Conclusion, therefore, the car is a roadrunner. So what are the ideas that can be deemed true or false here? The car could be a roadrunner. Another idea, the car's fast. So, symbolically, premise 1, if the car is a roadrunner, then the car is fast. If P, then Q. Premise 2, the car is fast. Q. The conclusion that's drawn, the car is a roadrunner. P. Now we test via truth table. So symbolically, this will be if P, then Q, and Q, then P. This is good. All right, so we have 4 rows here. No individual negations, so we can go into parentheses. Within that big parentheses, we have another parentheses, so we'll do that first. Our only problem with the conditional is when true leads to false. So our second line, everything else is good. Then and Q, we can pull that together. There's the symbol we want, and Q. So we're pulling together of P then Q, and so it's only true when they're both true. True, and the third. And then now we can do the big picture. If P then Q, and Q, then P. And the two that we're focused on are the one we just looked at as the first one, and P as the second one, going backwards. Our only problem is when true leads to false. We're good. Problem and everything else is okay. So ultimately, is this a valid conclusion to draw? There's at least one false in there, so this one is invalid. And you might be wondering, well, this was one of the standard forms of invalid arguments, so couldn't I just say invalid right off the bat? It says test validity using a truth table, so you would have to show the work, including the whole truth table. And definitely you can see through this example that it's clear that this doesn't work. If the car is a roadrunner, then the car is fast. Okay, the car is fast. That doesn't necessarily mean the car had to be a roadrunner. Other cars are fast. So deciding that the car must be a roadrunner is invalid. It could be a roadrunner, but it's not necessarily a roadrunner. That would have to be the case true in all cases. All right, and then the other one, we're drawing a conclusion and showing the standard form of argument used. So if you go to college, you get a job. If you get a job, you can get a car. The ideas that we can deem true or false here are going to college, getting a job, and getting a car. So we have premise 1, if you go to college, you can get a job. College leads to job, we hope. Second premise, if you get a job, you can get a car. Q leads to R. And now we're drawing the conclusion. So this is going back to that list of standard forms of valid argument and seeing which one fits here. And the one that'll work, the conclusion we can draw, is that P must lead to R. Taking that back to words, if idea P, you go to college, then, oh, you don't need the comma. R, you can get a job. You can get a car. So we've done both things here. We drew a conclusion. If you go to college, then you can get a car. And we showed the standard form of argument that was used over here on the left-hand side. We didn't necessarily have to set this up on the first problem, but we did need to set it up and then test via truth table. So this video kind of summarized what this chapter was about, ultimately being able to determine if something is valid or not, looking at putting that lawyer hat on and deciding, based on all of this information, is this a conclusion I can draw, or coming up with a conclusion that you could draw. So I'll see you soon for another video.